Momentum and force. Physics made understandable with insights. Momentum is defined as mass times velocity, two very basic concepts in physics. The symbol lowercase p equals mv. Momentum equals mass times velocity. Since mass is a scalar and velocity is a vector, momentum is a vector in the same direction as the velocity. Momentum is conserved. The sum of all the momentum before and after an event, such as a collision, is constant. Moreover, momentum is a vector, so the momentum is conserved in every direction. Let's look at an example. An object with momentum 375 kilogram meters per second strikes a stationary object. After the collision, the object initially in motion has momentum 243 kilogram meters per second. What is the final momentum of the object that was struck? Well, these numbers represent components of the vector. So in the x direction, we have 3 plus 0 equals 2 plus a, or a equals 1. The y direction, 7 plus 0 equals 4 plus b, is satisfied when b is 3. In the third direction, 5 plus 0 equals 3 plus c gives us c equals 2. Or the momentum of the struck object becomes 132 kilogram meters per second. The x direction, the y direction, the z direction. The momentum in every direction must be conserved. Force is defined as the first derivative of momentum with respect to time. So the force is the derivative of momentum, and that's by definition. That's where force is actually formally defined. This momentum is a product, mv. Force is, according to the product rule for derivatives, m dv dt plus v dm dt. Recall from kinematics that the acceleration is the time derivative of velocity. When mass is constant, dm dt is 0, so v dm dt is 0, and F becomes ma, the familiar equation. For a rocket problem, mass is not constant. We find the change of mass and the exhaust velocity to find the thrust or force lifting the rocket. The force is V dm dt. Now, from forces change of momentum with respect to time comes the impulse equation. Ft is properly named the impulse, is the change of momentum. If I look at the integral of f dt from 0 to t, I get ft. And if I look at the integral of the first time derivative of momentum with respect to t dt, I get the change of momentum, or the final momentum minus the initial momentum. Newton's three laws must be consistent with momentum, the definition of force, and the conservation of momentum. An object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity unless acted upon by an outside force. This can be thought of as a manifestation of conservation of momentum and the impulse force. If the momentum of an object is to change, there must be a force, or equivalently, to change the velocity, there must be a force. Force is proportional to the acceleration, and the proportionality constant is the mass, provided the mass is constant. Or in other words, F equals ma. This comes from force is the first time derivative of momentum, which is ma plus v dm dt, which is ma when dm dt equals 0. When an object exerts a force on another object, the second object exerts an equal magnitude force on the first, but in the opposite direction. Since momentum is conserved, when two objects exert a force on each other, the total change in momentum is 0. Since the impulse equation Ft equals the change in momentum gives the force of one object on the other, the second object acts on the first with a negative change in momentum, so that momentum can be conserved, of the same magnitude, which requires the force of the second object acts on the first to be a negative F, since negative Ft is equal to negative the change in momentum.